In this video, I want to give us a preview of the vocabulary we're going to be exposed to when we're describing the behavior of functions using their derivatives. So this is going to be just kind of a core dump of some vocabulary terms. Don't worry about memorizing them at this point. We will define them with more precision in later videos. But I just wanted to be able to look at the graph of a function and let you have some sort of intuitive sense for what features of a graph we're going to be describing using the vocabulary for this unit. So let's take a look at the function that we have in mind. So here's the function I'm going to be talking about over the course of this video. And so the first graph I have here is highlighting all of the places where the output value is greater than 0 in pink, and highlighting all of the places where the output value is negative in blue. So can you imagine what kind of vocabulary I would use to talk about these sections? Well, the pink section is going to be where I talk about where the graph is positive. And the blue section is if I would ask about what portions of the graph are negative, just talking about whether the output values are positive or negative. Where they meet, this is definitely language we've talked about in Algebra 1. We will find ourselves calling them the zeros of the function. Sometimes we'll call them the roots of a function. So these are going to be common words we talk about for talking about where the value of the function is exactly 0. Okay? We're not going to talk about this in a lot of detail. I just wanted to make sure that we talked about how these are important features of a graph. All right, this is the same graph as before, but different highlighting. Looking over this, can you see what I highlighted? What's important about this graph that made this sections either pink or blue, and what language I could use to describe them? Well, as we're going from left to right, this is the portions of the graph where the function is going down in value. And then it stops, and then it starts going up in value. Once again, stops, starts going down in value, and finally ends up going up in value. So the pink areas are going to be, we're going to describe that as the intervals where the graph is increasing. That means its value is getting larger over the interval. And blue is going to be the intervals where the graph is decreasing. All right. And what kind of language do you think we should describe for these circular points where it's switching from one to the other? Well, in general, we can find ourselves calling them turning points. Another vocabulary we'll use around this idea is we'll call them, critical points. Although the definition of critical points is going to be a little bit different, but it's closely related to this idea. And there are other specific words we're going to use. Like for instance, this point up here, I want to call a maximum, because this is the highest value. Well, it's not the highest value anywhere in the graph because it gets higher over here, but you can see here that it kind of has a top peak and then goes down on either side. So the word I'm going to use to describe that is I'm going to call this a local maximum. And local maximum just means that if I only focus on some small interval, including this point, it's the highest value in that interval. Okay, so that's what makes that a local maximum. How do you think I could describe this point down here? If you said local minimum, then minimum, then you get a half a cookie. That was pretty obvious. This point down here is not only a local minimum, we could describe this as a local minimum, but it's also the lowest point that the graph ever reaches. So we'll give this an extra talk. We'll call this a global minimum. Okay, so the global minimum means the lowest point that the graph reaches over the entire domain. This is also a local minimum because I can imagine some sort of interval around that point where that's the lowest point. So it's a local minimum, but it's also a global minimum. Okay, so we've got maximum and minimum points. And there's a special word we use that combines maximum and minimum points, and these are called extremum. So you can see how it's kind of has the maximum and minimum. It's got that mum at the end, but to combine both the highest and lowest points, we're going to say the extreme points. So that's extremum. And the plural of extremum is extrema. Okay, so these are words that you'll see. You'll also hear talking about the plural of maximum is maxima and minima. Okay, so these are all kinds of vocabulary we've got around turning points. We've got minimum and maximum. The plural of that is minima and maxima. Those are both values. Those are both examples of extremum, whose plural is extrema. And then the other important concept we have is the difference between local extrema, where it's the highest or lowest point in some sort of interval around that point, and then the global maximum or minimum, if one exists, which is the highest or lowest value of the entire domain. Does this graph have a global maximum, do you think? Well, no, because it's just going up to infinity on both the left and right. So any point that you think would be the maximum, you could go higher just by going a little bit further to the left or to the right. So this is a graph that has a global minimum, but no global maxima. And it has 2 local minima and 1 local maximum. Okay, so there was a lot to say about that picture and a lot of vocabulary about it. There's one last section to talk about here. And so what we're describing in this graph is this blue section in here. You can kind of see that this hump that it has heading into this local maximum is kind of a downward cup shape. And this region kind of around these 2 local minima have this upward cup shape. All right, and so there's special vocabulary we're going to use for this. This pink section we're going to refer to as concave up or concave upward. We could describe that either way. And the blue section we will call concave downward. So the way I remember this is if that section of the graph looks like an upside right cup, that would be concave up. If it looks like an upside down cup, then it would be concave down. And we've got another word to talk about where it's switching between concave up and concave down. This is a word that sometimes you hear in history class or other social sciences, but we'll talk about that as an inflection point, a point when something important is changing. So the inflection point is when a graph switches from being concave up to concave down or vice versa. Okay, so that was kind of a core dump of vocabulary. As I say, we'll be covering it all in more detail in future videos, but I wanted to give you those ideas about features of a graph that are worth having vocabulary terms associated with them.